Okay, well, thanks everyone. It's really good to meet you. Cowbell Labs was originally meant to be a focused research organization, a 5-year, $40 million project in the space. Unfortunately, philanthropy's restructured, and so what I'll present you is more of what we got to and a lot of what we did in terms of a landscape thoughts. And so we can talk about, basically what are these needs for livestock methane measurement towards kind of the two main purposes. One is research and one is market development. And you can find me at any of these places. So, I mean, I've been working in agriculture for 10 years. Agriculture, compared to a lot of other industries that do measurement, doesn't have a lot of money. So I've always thought that the best bet was to try and borrow things from fields that do. And in this case, when it comes to methane measurement, there's a lot more money in fossil emissions. So the question I tend to think about is how do we adapt methods and approaches quickly, more quickly than they would otherwise without focus on them to agriculture, right? And so I think a lot of people are pretty familiar with these kind of approaches, ranging from satellites to near Earth testing, such as UAVs or open path lasers, as well as emission evaluation centers like the one at Colorado State, METEC, and of course, algorithms to take this data and make it interpretable and useful and insightful. So I know there are a few people on this call who know quite a lot about livestock methane already, but I'm just generally assuming that more people on this call know more about measurement than they do about livestock methane. So I should give you a little bit of essential background to contextualize. Of course, I'm going to assume that everyone thinks methane is an important greenhouse gas. I think that's kind of table stakes in this room. So, we'll start with our star of our show, which is a cow. So a cow's got a special stomach. It is an anaerobic digester. And as a result of that, it is creating methane. And it needs that kind of stomach to eat grass. So anything that eats grass will create methane. They burp about once a minute, each over a day. On average, they're doing about 10 grams of methane per hour. Compare that to oil and gas, which is usually people looking at sources 1, 10, 100 kilograms per hour, right? So either you need a lot of cows to reach that same level of emissions as a leaking piece of fossil infrastructure, or you need to or you need to have a bit more sensitivity, right? So we're at the lower end of sensitivity of this kind of measurement equipment. And the cow is essentially doing that, right? It has a pretty high concentration level. And, in some degree, you could read its burping is to prevent it having truly dangerous levels of methane build up inside its stomach. So we know cows are burping methane, right? This isn't like an oil well where the question is this leaking or not, right? We know it's burping some amount of methane. Our question comes when we try to apply solutions or mitigate is just how much. So it becomes more of a quantification question. Um, you know, Overall, the impact of over 1 billion cows is something like from the burps, 0.17 Celsius, and that comes from Spark Climate Solutions analysis of numbers in the IPCC report for policymakers, right? So it's significant. It's bigger than oil and gas methane emissions, right? So, one big challenge is most cow burps are in hard to reach places. So when we think about cows, we think about feedlots and dairies, which tend to be very, very visible, but those are actually 20% of the methane emissions. If you put all the cows in them together, you start to get to significant signals. Most of the emissions is actually beef grazing animals. Roughly 80% of it, people can definitely argue about those numbers because the inputs for them, like how many cows are there in Africa, are a little, they're not accurate for sure. And so that gets you a lower signal. And I'll make a quick note that manure is also a part of emissions. It's a much smaller part, and it's really only on this left side. It's really only in feedlots. When we're out in field, nature takes care of degrading the manure, so it doesn't produce nearly as much methane as it does when you have a manure lagoon. So we know that methane reduction solutions are possible. There's some on the market. There's other people developing more, right? The premier commercial one is Bovaer, right? Which is roughly, 25 effect on dairy, 80% reduction on feedlot. I do think there's room for more and better solutions, but really that's a topic for another day. Maybe a different speaker. Maybe Charles Brook at Spark actually would give a pretty good talk on that. And that variability can be really high. If you took like two random cows on planet Earth, you could easily get a 5x different in what they were burping in that moment. And that's from everything from the size of the cow, how recently they ate, um, uh, what type of food they're eating could be very, very dramatically different. I'll show a graph about that later. Uh, uh, but there's also just two very cows to like, if you're in America, a black and white cow, you could see a 30 or 40% difference in their emissions between any two. So there's a bunch of factors that are probably genetics of the cow or in the microbiome of the cow, which definitely people are working on trying to target those as means for interventions. And all these factors will have some interact with these kind of silver bullet methane solution, these a pill that you feed a cow, a special additive, whether it be the seaweed that's very common in the press, or Bovaer, which is further along in its commercial journey. So we kind of have two use cases, right? Just splitting it up. One is R&D, and generally there, our goal is to compare groups of cows or single cows with another, right? Maybe single cows to build up some model that takes in all these factors, or if you're testing a product, you have a treatment group and a control, so you're going to want to somehow take a herd and, get individual cow data and sort of like slice it up quite a bit in order that you can do that kind of analysis. If you're talking about markets and emission inventories, you're much more looking at confirming what the emissions are. So you really care, what is that number on that herd? You'd like to have an error bar associated with it, because 100 kilograms plus or minus 50 kilograms, 100 kilogram plus or minus 5 kilograms are very different things. So you get to, and that changes the sort of techniques that you would use. We can talk a little bit about what's out there right now. There are 3 accepted methods. They're costly and they require quite a lot of deep experimental expertise. I don't know why I wrote that there, doubling experiment costs. One that's pretty popular, mostly outside the United States, SF6 tracer method. These are sheep. Sheep also burp methane. So you're putting a backpack on a cow. The daily fee is at least $5 per measurement. The CapEx is relatively expensive, but it's using a mass spec that a lot of people have, right? So you may not need to start this. Someone doesn't need to buy their own equipment. A rep is kind of the gold standard. This is the one at Cornell, and that's where you put a cow literally in a box and measure what's coming out, right? That's fairly expensive. It's essential for research. It's certainly not scalable. You certainly have to do a lot of things like manage the cow, acculturate them to the chamber. And then there's a green feed. Oh, and there's me with a green feed. This is getting very popular. They're pretty expensive, and they, aren't really compatible with farm operations. They're just too much effort to bring to a commercial farm. And, every time I talk to researchers about these methods, they have some complaint. No researcher is like happy, but researchers will, of course, put up with more difficult things than a farmer. So get a sense of like, where do we need to be on cost, right? I got some numbers from Texas A&M, right? Quoted me out, right? So animal maintenance is kind of your baseline, about $10 per day, with, SF6 and green feed roughly costing that per day per animal, right? You'd like to be lower than that, because if you were a tenth the cost, for example, then it would go from like its own experiment to just an add-on you would do to other experiments, which would really increase the volume of data. And a highlight is that, only really the SF6 is fully pasture compatible. right? So where we want to head is not only methods that have these kind of cost targets, right? $10, which is $1,000 for 100 cow herd. It's not unreasonable, and are relatively simple to use. So you could go fly a UAV over a farm, right? But installing a green feed over that farm is going to be pretty tricky. So, like how, then what's happening today to make an offset is you take your data from the research farm, you create a methane model with it and use other data put into that methane model. So, someone has characterized the effect of the cow breed, right? That goes in the model. And then if you measured your candidate solution, that will go into the model. You take in farm data and you get some estimated herd methane. So that means that there's no real audit, right? We're not really checking, is this actual number that we predict from the research what we're seeing on the farm, right? And that gets to big questions about transfer learning, like are they really the same, right? Are the conditions in the research farm really the same as the actual farm? And so it's a possibility for error. It's like a pretty simplified view of this is that you basically have an arithmetic equation where it's how much they eat, what they eat, which is, of course, pretty hard to measure for grazing animals where they're eating grass and you're not just putting a set amount of feed in a bin. You'll have a set of corrections, and this is obviously a simplification, but for example, breed and then some treatment effect, right? For Bovaer and dairy, that's, reduces by 25%. So, for methane MRV, we certainly won't measure every cow like we would hope for every leaking gas well. And that comes to an economic calculation. If you do the math, and I have a calculator that I can share, an online calculator I can share for this, the offset value of methane reductions is less than typically 5 cents per day. Your measurement needs to cost a fraction of that. And so we'll likely see things move in the direction that Soil Carbon has moved, right? Indigo Ag, who I advise, does something like this, where you're bundling up a set of herds, you're collecting some data from them, you're plugging that into the methane model, and then you're getting some aggregate methane. And then on top of that, we'd want the methane measurement to not only be building the model, but spot checking. So sort of saying, making adjustments on some subset of farms, right? Not every single farm. I mean, every single farm would be great, but as many make economic sense and add to the accuracy. So that's the background. So I'll get you into our program and our insights. So as I said, the hypothesis is technology adaptation. So, we're keeping track of a lot of things. We're watching methane satellites. Obviously, there's a couple of people in this room who are way more involved with that than us. In terms of bringing it to Africa, we've had some deep conversations with ILRI, which I think Joe Ruddick is pretty well aware of. Adapting these near Earth techniques, which is really kind of a heart of our program, and sort of building on the METech test site to a MUTech test site, which is Dan Zimmerle's name. So give credit who runs METech, credit where due. Modernize the livestock methane models. And we also have a project that we've canceled on developing cattle wearables using lower cost methane components, which we still think is a tractable approach, and we'll get into that. So this is the number one question, and I get from a lot of people, is why not just do this with satellites? I'm a big fan of satellites. I actually donated to EDF when they announced MethaneSat because I was so excited that they were building a global methane measurement system years ago. So roughly, if you take a Dan Jacob from Harvard's numbers, you could detect her 50,000 plus cows. You're not going and getting a single farm. You're not using that for research. That's county level quantification. That would be if that can be done, that'd be incredibly valuable. The EDF is, I know, working on this with partners in New Zealand, and I'm just watching and waiting. The other possibility is Carbon Mapper, which, while the methane sat's a global coverage satellite, Carbon Mapper is more if you task it to a location and view it in a bit more depth. That should be a bit more sensitive, and could be able to verify potentially larger farms. It's not a priority for them at this point, which makes sense given they have only a limited number of places they can task to. Whereas with methane sat, they're collecting the data, so it's easier to use it for secondary applications to their main mission of oil and gas. And that's really all I'll say about satellite for the time being. So we asked about near Earth measurements. Those are your UAVs, or one technique we've thought about a lot is an open path laser, which is basically you set up two towers and you shoot a laser beam across it and it absorbs along the path, which gives you more sensitivity because it's integrating the methane along the path, right? So we want to know, like, first cut, is that like sane? Is that like, are we just totally out of our minds? This is possibly the right sensitivity. Some folks went to Kenya and they set up an experiment there. Cows in a lot of the developing world are put in enclosures at night. So the cows aren't lost or were stolen, right? Because they may have, big cows grazing huge areas of open terrain without fences or guardians. This really requires a lot of rule of law and social systems to pull off, right? So they went and they did this experiment, and then, the wind, in principle, the wind blows across the enclosures and the methane should go up. So they did this experiment, and the results were reasonable. Remember I said cows were about 10 grams of methane per hour. They got about 8.6, and I expect Kenyan cows to be at night to be a little lower than that, on the lower side of things. The error bar is about 20%. Typically, we want more like 5% or 10%. So it's a little high, but there's a lot of optimization that hasn't been done there on things from algorithms to sensor placement. So we looked at that and said, okay, that probably could be done better. And we've also seen there are positive pre-publication results for UAV, but can't share those at this time by a collaborator. The other thing we did, because we knew that a boma with this tight enclosure was not really the same as a pasture instead of cattle in terms of cattle density, is we did a really simple simulation. We use WindTrax, which is, a common tool for, estimating, where emissions go based on the turbulence and the wind speed. So pretty simple to use. Basically, we put 50 cows in a corner of a 1 hectare field, which is about a reasonable size for a pasture, and then simulated laser lines across it and simulated point sensors on the perimeter and asked, and from that we could ask how sensitive these sensors would need to be. So results of that, first on the point sensors, which I don't show in depth here, needs about 10 ppb sensitivity. So that's, can be $100,000 sensor. So we're not putting $1,600,000 sensors on the edge of a field. You might put it on a UAV. So stop on that. And we didn't really expect it to be that high, but it'd be very high, but it made sense to check it given it was really easy to in the simulation. And then there's 2 commercial open path lasers that I'm aware of. There's a few that seemed reasonable. One is by a company called Boreal. One is a company called Miraco, which this red dotted line is actually about. They have some reported numbers. We took some reported numbers from papers, and indeed, for 50 cows, our bars here are higher than our their detection threshold. So that's positive and indicative that this was a good thing to follow up on. So what we want to do next is actually test that out in the field. That means finding a partner who's pretty good at cattle management experiments, like AgNext at Colorado State, which does beef experiments, and they have a lot of pasture systems, and they have a lot of these green feeds to then measure it. And so you could get a baseline number, right? One of the problems with the BOMA experiment is we don't know if they were accurate because there's no reference that they're comparing to. And the other thing we do is put GPS ear tags on the cow, which are commercial. You can buy them for maybe $100. And that would get us cow tracking data. And so that would clearly, the easiest goal is accurately measure the full emissions of the herd, right? Which if you can't do, you should just stop. And then the next question is, can we get below that herd level by correlating locations of the cows with locations of the emission measurement? And if you can get to a subgroup level, so treatment versus control, then you have something that's valuable for research. The third thing we were thinking about is that GPS data would be helpful for designing a controlled release test site. So I know a lot of you are familiar with the Methane Emissions Technology Evaluation Center, which was a big inspiration for our thinking on this. That's at Colorado State, and what they do is they have synthetic emissions that mimic oil and gas infrastructure, and then groups doing near-Earth observation come there and test their technology against it. And because the emissions are known, they can, basically get a real accurate report on how accurate they were on taking that kind of test. We thought the same kind of approach will be helpful for cows. METEC has a number of advantages in terms of they already know all these vendors, they already come there, and they have sent and they also have figured out how much it would cost to build. So they're ready to go, and they're conveniently located next to Colorado State University AgNext, so you can move things between cows and synthetic females. And that gets you to a robot cow, which I'm excited about as maybe the 7-year-old inside of me. But the upshot of that is, again, you can get a lot more data. If we're measuring, if it takes us 30 days of the green fees to be like pretty sure what that cow was emitting from robot cows, right? We would get it every single several minutes. We would get a data point, and so you can develop your algorithms faster, or you can qualify it a lot faster, and then move on to the cows once you've shown that you can really get it on the synthetic cows. We are concerned about cost of building this. We got, definitely reviewer comments on our proposal that we had some really aggressive, like year 5 cost targets for this. So I went to Harvey Mudd, which has an undergrad clinic program, right? And which is a great program. These kids did great, and they really want climate projects, actually. And for projects they really want, they'll sometimes get a donor to fund the sponsorship fees. And so they didn't know it was impossible to build what I wanted them to build, so they went and built it. And so they got a $400 mass flow controller that was across 4 orders of magnitude of emission rate. And I think the really fun part was they have some control circuitry, and you get to watch the gears turn, which just makes real physical the principal controls. An actual cow will exhale at 1 hertz, which certainly the system cannot do, but we don't really, Dan or me or any of my collaborators, think that's necessary for anything but like a sensor that's basically right on the cow's face. And if you did want that, actually MIT built one of those, and so that could be built again, should it be needed. So okay, so we have, let's say we want to move forward with this test bed. We would take in that data, run it through a simulation system based on the real data and our research on the profiles of livestock methane emissions over time of day, right? And so then you get an actual real simulation of, you can start to ask what the emissions would look like, and you can start to ask where would you place the sensors to improve accuracy. And we see that as like a useful tool that could eventually be there for anyone deploying emission measurement technologies. And then you can also, as I said, put it out, test it out in the field. In terms of the computational side of this, my collaborator, not on the building a program, but on the interpreting the data and doing the inversions of these plumes to do source attributions, John Abosin at Cornell, who's been a leader in this field for a couple of decades at this point. So let's say you would take your satellite or a UAV and you make a measurement, right? You've made that measurement at some time point. The challenge, and let's say that's perfectly accurate, you've totally solved that problem. You then have another problem, which is that measuring at 6 p.m. and measuring at 10 a.m. on the same set of cows might give you quite a different value. That can be quite significant. So here's just one paper, that kind of draws attention to that. And in this paper, they fed 4 groups of cows, 4 diets with increasing amount of wet distiller's grain, which increases methane level. So you can see that, the difference in methane levels, which is the y-axis between the treatments, is quite high. About 4 to 6 hours after feeding is peak emissions, which is roughly what you expect given how cows digest. But you can see we've got, kind of a 2x between here and here. This is a bit of an extreme example because most cows aren't eating once a day. Cows basically try and eat all the time, but there's a real source of error here that could turn an accurate single point measurement to a pretty inaccurate multi-point measurement, which means you could solve that by doing a lot more measurements, but that's expensive, right? So there's this first goal that you'd have to correct the time points. Now, the Global Methane Hub is doing some work towards that based on green feed and restoration chambers, focused on the green feed. And the hope is that can then be used and translated towards satellite measurements and UAV measurements to account for these kind of issues. So I've mentioned as well that I talked about modeling earlier. A lot of these models, one of the problems is that, a model only works if you have the inputs. A research farm, you are going to have a lot more measurements, a lot more accurate measurements on inputs, what the cow is eating, than you are going to in a commercial farm. So any commercial farm verification model should run on things that are easy to collect, or the farmers or people will not bother, or they'll just use a flat figure and call it a day. That means that likely where you want to start is with a model that uses the outputs that we routinely measure, most notably the amount of production of the animal, so the milk of the animal, which is going to be highly correlated to the methane. This brings you to a more complicated modeling problem, which I decided that going through and talking through all of how the factors that affect cow methane in detail would just be a little bit of a distraction, and a slide with lots of boxes with arrows, which would be a little bit inscrutable. But it does complicate the issue, but the models we build need to be usable in the commercial space, or we'll use simple models that are inaccurate, which is what we do today. And you want to be this in a framework that quantifies errors. And the reason for that is financial. There are 3 tiers of offsets. a lot of what is being done today is tier 1 or arguably tier 2, which is tier 1 is like a national emission inventory number, which is okay for national emission inventory. It's not okay for did farmer A have this reduction in methane. Tier 2 is using more local data, and tier 3 has a verification. And as you get up those levels, it becomes financeable, which means groups like the World Bank feeling confident enough to get involved because they can push this through a risk table. They can estimate their effects a little bit better. Generally, we see that the current market for emission reductions tends to be more food companies, which are trying to reduce their emission intensity. Cross sectors, they are a little less assertive on quality. I won't say more than that. And they also support a little bit higher prices. So almost everyone who's building solutions in that space is looking at them as a beachhead market. And we kind of know that this sort of increasing the quality can bring in customers from the example of soil carbon. So Indigo, which I advise, has built such a model on soil carbon, and they've managed to sell quite a few offsets, right? They have a real business going there, and they've managed to get customers who are pretty discerning on quality. So notably, Microsoft has fairly high standards on offsets. Not everyone does. Some have very, very low standards and will buy whatever to purchase them. So we see this trajectory happening, and I expect as we develop gold standards ways of quantifying that people will adopt them. So I did mention that we had worked towards a wearable sensor as well. We just did a very sensor test and a very basic prototype in California with Brian Fiscalini of Fiscalini Cheese. And that's essentially just putting a halter in a cow, an intake gets pumped into this box, and we put a reference sensor in there, an Xetris, which is fairly accurate, and we could put whatever other sensors we want in there. We wanted to see first, could we do this with the cheap sensors, right? These less than $200 sensors. We were like not that optimistic, but we needed to know. And before that, we had evaluated 100 sensors by spreadsheet, and we brought in 7 sensors across a diverse set of modalities. The results were poor, discouraging, even though the lab results had been fairly encouraging, right? These levels on the left are a little low because that intake was not optimized at all. So we're definitely not getting the full methane breath from that methane burp from that cow. But, we're seeing what we expect from the reference sensor, like every minute it's getting a burp, which is what you think you should see. And you can see the little sub peaks, which are coming from its normal once per second breathing cycle, while the dynamite sensor, that just terrible. So, the next steps we would have taken is, just improving that air intake system, so we could bring the concept with the Xetris sensor to a respiration chamber at Cornell, integrating humidity and temperature sensors, because a large part of what is likely happening is that most of these sensors are cross-sensitive to humidity and temperature. When a cow breathes out, it is also spiking, rapidly changing that. We also then identified a somewhat more expensive sensor, which might have done the job, which was the Smart Gas Flow Evo, which has a pretty high speed and this moderate sensitivity, which we thought might have been able to do the job. We didn't get funding, and Zelp got millions of dollars of funding. So, falling behind, we decided to end the project. And, I think they're doing pretty well at getting a prototype out there. So I wish them good luck, because this sort of, from our talking to farmers, they really could see a compact wearable that's kind of like a halter being a tool they would use on their farm, which makes it very different than every other tool that we had seen before. And of course, it becomes much more pasture accessible than anything, including the sulfur hexafluoride tracer system, which is the current best there. So like in my basic conclusion is I think this is a solvable problem. It's really just a matter of the dedication and effort needed to do so. We need these easy to use measurement methods for models into audit farms. I will say that offset markets are not always the most aggressive in pushing for quality. So that's why I tend to think that it is more of a they will adopt an affordable, accessible gold standard. And so it's more of a push than it is a pull, right? Which is why we were structuring as a part of why we were structuring as a nonprofit. And we know that the existing measurement technology has the required sensitivity and really hasn't been optimized for this problem. We have a plan. I think we still have to do it to then build a validation testbed in collaboration with MeatTech and see that these modeling frameworks get improved so that we really can push them into MRV markets and get high quality verified emission reductions. So I'd like to acknowledge some people, my collaborator, John Albertson, Brian Fiscalini, Charles Brook at Spark, who I speak to every week and is my constant thought partner in all things cows, and Dan Zimmerly at MeatTech for engaging with us and helping us think this through. Cowbell Labs was incubated at Spark Climate Solutions, funded by Spark, Schmidt Family Foundation, Lyda Hill, and here's the team members who actually did a lot of the work that I showed. So that's all I have for you today. So any questions you got, I'm here for them.
Amazing. Thank you so much. I learned a lot. Philippine, if we could stop the recording whenever you have a chance. Any questions?